Hi, everybody. So today we are going to be talking about graphing systems of linear inequalities. So up to this point, we've only talked about systems of linear equations, so equal signs. But linear inequalities really can only be solved in a graphical manner because you cannot do substitution or elimination when there's an inequality symbol. So that means for pretty much all of these questions, we are going to be graphing and finding our solution points. So if you remember back when we were graphing single inequalities, we would put an S in the shaded region. Well, now what we're going to end up doing is put an S in the double shaded region. And that's because we're going to have overlapping shaded areas, and anything in the double shaded area is considered a solution. So there's going to be multiple solutions, and I'm going to talk about that as we go through a few examples. Now, we also have to remember when we're graphing inequalities, if it is less than or equal to or greater than or equal to, it is a solid line. If it is less than or greater than, but not equal to, it is a dashed line. If it is less than or equal to, we shade below. And if it's greater than or equal to, we shade above. We are going to have to do 2 sets of these for every single question. So it might benefit you to have 2 different colors. I am unfortunately going to be using a very similar color I don't have 2 contrasting colors. One's blue, one's purple, so it might be a little bit difficult to tell the difference, but I'm going to try and talk through it as we go. So in number 1, we're going to start off very straightforward. Y is greater than or equal to 2. There is no X in that problem, which tells me that this is a HOI, or a horizontal line. Since it is equal to, it is going to be a solid line, and since it's greater than, we are going to be shading above it. So this is my purple pen. I know it looks blue. Sorry. So we have a horizontal line at positive 2 on the y-axis. It's solid. And I'm going to label it. And we said shade above because it's greater than, so I'm going to shade above the line all the way across. The second equation, let's see how different my pen looks. You can tell a little bit, I guess, that it's different, is a vertical line at negative 3. It is going to be a dashed line because it's not equal to, and since it's less than, it is going to be shaded below. Well, actually, I shouldn't even say that below, because if it's a vertical line, let's draw it, 1, 2, 3, vertical line and it's dashed. I'm going to label it. If I'm trying to think where things are less than a vertical line, you actually want to think for vertical lines only. Where are the numbers smaller than negative 3? And the numbers that are smaller than negative 3 would fall to this side of it. And what I find is my double shaded region, I'm going to use a highlighter on this one, is this like upper left corner. That's where my shading overlaps each other. That is where I'm going to put my big S. Any point in that double shaded region is considered a solution. So I could pick negative 1, 2, 3, 4, up 1, 2, 3, 4. This point right here falls in the double shaded region. So a solution would be negative 4, 4. I could be really dramatic and pick negative 10, 10 if I wanted to, as long as it's in the double shaded region. Now, we had this conversation way back when, if a point falls on a dashed line, it is not a solution point. So anything on this dashed line would fail. Any point on this solid line actually would be okay. Please, I ask you right now, be safe about the point that you're picking. Just pick it in the double shaded region. When you are doing linear inequality systems, do not pick the point where they cross, because in case you graphed wrong and you made both lines solid by mistake, your point is now also wrong. So please, please, please just pick in this double shaded region, then you don't ever have to worry about it. Okay, let's try one where it actually has a slope this time. So the first equation is ready to go. It is in y isolated form. So we have a y-intercept of 1 with a slope of up 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1. Don't connect your dots if you're going on ahead of me, because we haven't talked about solid or dashed yet. Because this is a less than symbol, it is going to be a dashed line and shaded below. So connect your dots with a dashed line, label it. And if that's my roof, if that was my rooftop, where would I be if I was below my roof? I would be on this side. Switch to the other equation. Technically, this other equation has a y-intercept of 0 because there was nothing written after it. So I'm going to start at 0, 0. And from there, my slope is up 1 over 2, up 1 over 2, up 1 over 2, all the way across. Don't connect your dots just yet. And this is a greater than or equal to. So if it's equal to, then that means we're going to have a solid line, and greater would mean I'm shading above the line. So solid, connect your dots, solid. Label. And if that's my rooftop and I'm above my roof, I would be shading on this side of the line. So now you have to look where the waffle is. Where do my shaded regions overlap each other? My shaded regions overlap in this upper sliver, okay? And technically it goes forever in that direction, but that goes off the grid for us, which we're gonna just not worry about. And we're gonna put our S in the double overlapped shaded region. So again, pick a point in the double shaded region. So wherever I just highlighted, pick a point, any point. 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5. That sounds like a perfect spot right there. 5, 5 would be a solution point. Anything in the double shaded. Okay, so we're going to do a couple more examples like this because the bottom ones here require a little bit of rearrangement before I can just jump to the graph part of it. So number 3, I need to get y by itself. So subtract 3x to the other side. Divide by a negative, and I've said this a million times, if you divide an inequality by a negative, your inequality has to flip. So your alligator's going the other way. Negative 3 divided by a negative 6 is a positive 1/2. 12 divided by a negative 6 is a negative 2. That's my first equation or inequality that I'm going to graph. Now that it's a less than symbol, it is going to be a dashed line. We're going to shade below. So I'm going to finish up this one first and then go to the other one. So it starts at negative 2 on the y-intercept. The slope is up 1 over 2, rise over run. We said it's a dashed line, so I'm going to connect my dots with a nice dashed line. Label. And shade below. So if this is my roof, below my roof would be down here. Again, we got to rearrange the second equation here. So to get y isolated, I would have to first move the 3x to the other side. I'm left with a negative y is greater than or equal to negative 3x plus 2. I'm about to divide by a negative 1, so the alligator will flip. Now remember, if I'm going too fast, please just pause the video, okay, so that you can catch up. I don't want you to miss something because you're just like scrambling to write everything down, okay? So y-intercept is negative 2 again. Cool. My slope, however, is a 3. So 1, 2, 3 over 1, 1, 2, 3 over 1, up 3 over 1, up 3 over 1. Reverse it the other way. Because this is a less than or equal to, this is going to be a solid line, but less than means I'm still shading below it. So connect your dots, label, oops, this should be less than or equal to. And if this blue line is my roof and I'm below my rooftop, it would be a very steep roof, but it could happen. That's below my rooftop. So where is the waffle? Where's the double shaded region? Double shaded is just this bottom underneath both. So that whole area and beyond, but this is the only part that's within our grid space. So any point in that double shaded region would be considered a solution point for us. All right, last one where we have to rearrange, and then we just have 2 multiple choice on the next page, and then we are good to go. Three multiple choice, and then we're good to go. So number 4, get y by itself again. Now this looks a little backwards to me. I'm not a huge fan of the fact that it's not in our normal order, so I'm going to rewrite it one more time and put the -1/2 first and the +4 second, so that way it's in y equals mx plus b form for us. Dashed and less than means below. So y-intercept is 1, 2, 3, 4. Slope is down 1/2. Dashed line through those points. Again, if I'm going too fast, pause the video so that you can get yours plotted. Just don't want to make this too long of a video, which is why I'm going kind of fast. Dash line, shade below. Ooh, that's a lot of shading. All right. Okay. Second equation is almost ready to go. Add the 1 to the other side. That wasn't too much work. This time it's equal to, so that means a solid line, and it's less than, so I'm going to shade below it again. Lots of shading below on this practice day. Sorry if you heard that. That was my neck. Starts at 1. Slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1. Go all the way across. We said it's a solid line, so connect with the solid line, label. Shading below it, again, if that's my roof line, this is below my roof line. And where's the waffle? Same bottom corner as the last one. Pick a point, any point, just don't pick the spot where they crisscross, and you'll be fine. Pick a point in the double shaded region. All right, flip to the next page. We're going to do some multiple choice practice real quick. It says, which graph shows the solution of the given set of inequalities? So almost both of them are in the proper form. What I need to do on the top one is just get y by itself. So if this is the original equation, to get y by itself, I would just have to move the x to the other side. Okay, so let's have a conversation. This inequality is a greater than, not equal to. So that would represent a shaded line, or I'm sorry, a dashed line shaded above. It has a y-intercept of 2 and a slope of -1. So if I go over to my graphs, I guess I should talk about this one next. This equation, that inequality is a less than or equal to, so that would be a solid line shaded below with a y-intercept of -2. Use your context clues. If one of them is supposed to be dashed and the other one is supposed to be solid, then obviously 1 and 3 are not going to be viable solutions because both lines are solid. So those are out. Let's take a look at 2 and 4. Okay, so our line that has the dashed line, so we're talking about this one now, has a y-intercept of 2, which this one does. It has a slope of down 1/1, which this one does, but it says it should be shaded above. If this is the line, I would hope that you'd agree that that is being shaded above. If I take a look at our other option, that same line, however, is being shaded below. We said it should be shaded above. This one's out. And so by using those little clues, I can basically it's like process of elimination here. So we're going to do the same idea, but on number 2, using our context clues. Now, our first defense on the last one was, look at the inequalities. This one is underlined and this one is underlined, which means both are solid lines and all 4 options have solid lines. So that is out. Let's go on to defense number 2. Less than means I'm shading below. Greater than means I'm shading above. So if the line that has a y-intercept of 3, so find the one that has the y-intercept of 3, here it is. Okay, here it is, here it is, and here it is, should be shaded below the line. So look at all of our options. Option 1, that line right there is not shaded below, it's shaded above the line. This can't be my answer. If I look at this line again on this one, it is shaded underneath. So this one might be okay. We'll come back to it. Option number 2 down here, here's the line. Our shading is below it. So this one might be okay. And number 4, it's shaded above it again. So this one is out. Now we'll go on to the other equation. The line that has the y-intercept of -2 should be shaded above. So here's the y-intercept. I'm going to use my other color. Y-intercept of -2 says it should be shaded above it. Oh, I already knocked that one out. That one's out. Sorry, that one's out. So I actually only have to check it on 2 of them. Y-intercept of -2. This line needs to be shaded above the line. That's exactly where it is shaded. Okay, if I check the other one just for fun, here's our line. It's supposed to be shaded above the line, and it actually ends up being shaded below. This one now, by process of elimination, is out. So number 3 is the only possible solution. Last one. What is the point that lies in the solution set? They are going to try and trick you on the Regents exam. Plot all 4 of these points. 7, 0. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Here's 1. That's A, or option 1. 3, 0. 1, 2, 3. That's this one. That's option 2. 0 up 7. 1, 2, 3, 4, 5, 6, 7. That's this one. That's, oh, no, that's option 2. This is option 3. And -3 up 5. That one's kind of laughable. That's not even like close to a shaded region, so I would hope all of you would be like, no. So really, I think you would be tempted only by 1 possibly to get you the wrong answer. So obviously 4 is not it. I hope you would not pick 2 because it's only on one of the lines. Remember, a solution to the system has to be in the double shaded. It's going to be tempting to pick that one because that's the point where it crosses each other, but this is a dashed line. Dashed lines, boo. So the only one that's true is option 1. All right, guys, I will see you tomorrow. If you have any questions, feel free to contact me or just wait for tomorrow and I will help answer whatever you have. Bye.